You open a website. The page appears. It feels immediate, almost effortless. But before anything reaches your screen, a journey has already begun. Your request leaves your device. It enters your local network. Within milliseconds, your information becomes a traveler, crossing machines, networks, and cities. Long before the first image appears on your display, the internet does not deliver information instantly. It delivers it extraordinarily fast, and speed is the result of architecture, not magic.
The internet has no central highway. There is no single route connecting the world. Instead, there are millions. Every request is evaluated. Every destination is calculated. Every path is compared. If one route becomes congested, traffic moves another way. If a connection fails, the network searches again. All of this happens automatically, in fractions of a second. The internet was designed to adapt, not by chance, but by architecture. Its strength does not come from one perfect connection. It comes from countless possible connections. Redundancy is not a backup. It is the foundation of resilience. Because a network serving billions of people cannot depend on a single road.
Every journey requires decisions. On the internet, those decisions are made by routers. A router does not store your information. It guides it, receiving millions of requests every second, calculating where each one should go next, again and again, across cities, across countries, across oceans. Each decision lasts only a moment, but together, they create the movement of the modern internet. Without routers, information would have no direction, no coordination, no destination. The internet is often described as a network. In reality, it is a conversation between millions of machines, constantly deciding how the next piece of information should move.
The internet is not owned by one organization. It is built from thousands of independent networks, internet service providers, cloud platforms, universities, governments, content delivery networks, enterprise infrastructure. Sooner or later, these networks must meet. They exchange traffic, share routes, and move information from one system to another. This happens inside facilities known as Internet Exchange Points. They are among the least visible yet most important buildings on the internet. Without them, networks would remain isolated. The internet would become slower, more expensive, and far less efficient. The global internet exists because independent networks choose to connect. Architecture creates interoperability, and interoperability creates the internet.
Not every network carries the same responsibility. Some operate locally, serving neighborhoods, cities, or regions. Others span entire continents, connecting countries through enormous fiber optic infrastructure. These are the internet's backbone networks. They transport extraordinary volumes of information every second, every hour, every day. Cloud platforms rely on them. Financial markets depend on them. Streaming services operate through them. Artificial intelligence communicates across them. The faster civilization moves information, the more valuable these backbone networks become. Most people never see them, but they travel through them every single day.
Distance still matters, even in the digital world. Information cannot travel infinitely fast. Every kilometer adds time. Every router introduces another decision. Every network connection influences performance. That is why engineers constantly optimize the internet. They shorten routes, increase capacity, reduce congestion, build infrastructure closer to users. Milliseconds become valuable because millions of milliseconds become human experience. A faster website, a smoother video call, a quicker financial transaction, a more responsive AI conversation. Performance is rarely accidental. It is the result of thousands of engineering decisions working together long before anyone clicks a button.
No network is perfect. Cables can be damaged. Equipment can fail. Power can be lost. Entire regions can become disconnected. Yet, most users never notice, because the internet was not designed to avoid failure, it was designed to survive it. When one path disappears, another path is calculated. Traffic moves, routes change, connections adapt. Thousands of machines coordinate automatically, not because someone is manually directing them, but because resilience was built into the architecture from the beginning. The strongest systems are not the ones that never fail. They are the ones that continue operating, even when failure becomes inevitable. That is why the modern internet remains one of the most resilient infrastructures ever engineered.
The internet is often imagined as a destination. In reality, it is movement. Every second, billions of requests begin new journeys, crossing routers, traversing fiber, passing through exchange points, traveling beneath oceans, arriving inside data centers, then returning, almost instantly. What appears effortless is the result of extraordinary coordination. No single machine controls the internet. No single cable carries the world. Its strength comes from countless independent systems working together as one. Because civilization does not depend on information alone. It depends on information that can move, reliably, continuously, at planetary scale. The invisible architecture of the internet is not defined by where information lives, but by how information never stops moving.
Every message follows a path. Every path depends on infrastructure. And every piece of infrastructure depends on another hidden system beneath it. The internet may connect the world, but it still needs something to cross the oceans. Without that connection, the global network would become isolated continents. Because the architecture of civilization is built one invisible layer at a time. And beneath the internet lies another extraordinary engineering achievement, one almost no one will ever see. ASTIROZ, decoding the architecture of modern civilization.